Welcome to iLecture Online, and here's a new topic for us in physics called the center of mass. So what we're going to learn here is how to find the center mass of a set of objects or a strangely shaped object. But in this case, we're going to start out with an example, fairly simple. It says, or it asks, find the center of mass for the four objects given, mass 1, mass 2, mass 3, mass 4, in 4 different locations, and what is the center mass thereof. So assuming that each mass here is like a point object so that all of its mass can be considered to be located at that exact point indicated, then the way you find the center mass, you have to do each direction separately, is as follows. The center of mass in the x direction is equal to the sum of the product of the masses of each object, so I'll say mass of I, from I equals 1 to n, however many there are, multiplied times the x-coordinate of the mass of each of these items. So you could say that would be x, and I like to put a little like squiggly line on it, something I learned a long time ago from a teacher way back. And so you multiply the mass of each object times the x-coordinate of the center mass of each of those objects, divided by the sum of all the masses of all the objects, I equals 1 to n. N being, of course, the number of the masses that you have. So what we're going to do in the numerator is we're going to multiply the mass of each of these times the x-coordinate of the center mass of each of those. All right, let's do that. So this is equal to mass 1 times the x-coordinate of mass 1, and I might as well write it out. Let me just go ahead and do it like this. So mass 1 is 2 kilograms. So I take 2 kilograms, that's mass 1, times the x-coordinate of the center mass, and so that would be 0 in this case, plus mass 2, which is this one right there, which is 4 kilograms. And I multiplied that times the x-coordinate of the center mass, and that would be 2 meters away from the origin. So it would be times 2 meters. Plus the third mass, which is a 6 kilogram mass. And that is then also multiplied by the x-coordinate of center mass, which is right above the origin. So that would be 0 again. And plus the final mass, which is M4, 8 kilograms. Times the x-coordinate of center mass, which is also 2 meters away, so that would be times 2 meters. And then we have to divide that by the sum of all the masses, so it would be the 2 kilograms plus the 4 kilograms plus the 6 kilograms plus the 8 kilograms. All right, so quickly recapping what we did. We had 4 masses. Each had its individual mass that were located at 4 different positions. Each mass, of course, has an x and y coordinate, and to find the center mass in the x direction, we have to multiply the mass of each of the masses times the x-coordinate of each of their center masses, and then divide that by the sum of all the masses. So let's go ahead and do that. So this is equal to, that's 0, that's 8 kilogram meters, plus that would be 16 kilogram meters, divided by, that's 10, that's 20 kilograms. And notice that the kilograms cancel out, and we're left with 24 divided by 20, which, 24 divided by 20, which would be, 1.2? 1.2 meters. So the center mass in the x direction is 1.2 meters to the right of the origin. So if this is 1 meter, this is 1.2 meters, so it'll be right around here somewhere. So the center mass will be somewhere along this line. We just don't know how high it is in the y direction. That will, of course, depend upon finding the center mass in the y direction. So doing everything again now for the y direction, the center mass, the y coordinate of the center mass is equal to the sum from I equals 1 to n of all the masses times the y coordinate of the center masses of each of those, and divide that all by the sum of all the masses from I equals 1 to n. Again, we're going to multiply each mass times the y-coordinate of the center mass of each. Okay, so doing that again, starting with mass 1, that's equal to 2 kilograms times the y-coordinate of center mass, and since that's the origin, that will be 0 as well, plus the second mass, which is 4 kilograms, and that's then multiplied times the y-coordinate center mass, but since it's on the x-axis, that is also 0, plus the third mass, which is right here, 6 kilograms. Now that one is above the x-axis, so it's 1 meter above the axis, so the center mass in the y direction is 1 meter, plus the final mass, which is 8 kilograms, and it also is 1 meter above the x-axis, so the center mass of this mass in the y direction is also 1 meter, and we divide the whole thing by the total masses, which is 20 kilograms. Simplifying that, we have 0 plus 0 plus 6 kilogram meters plus 8 kilogram meters divided by 20 kilograms. And you can see then, of course, that the kilograms cancel out, and that's 14 divided by 20, which is 0.7, so that's 0.7 meters. So the center mass in the y direction is 0.7 meters. So if I come over here, this is 1 meter, this is about 0.7. So if I draw a line across here, I can see that the center mass of these 4 objects put together is right at that location. So center mass is equal to, in the x direction, that was 1.2 meters, and in the y direction, 0.7 meters. And that's how we find the center mass of a set of masses like that.